Hello students, welcome you again in our last chapter. Our last chapter is the development of solids. Okay, myself Mrs. Garade. Now we'll start. Imagine that suppose you have a solid and it is enclosed in a wrapper of thin material such as paper. If this covering is open out and laid on the flat plane, the flattened out paper is the development of the solid. To understand this, we'll take an example of a prism. Suppose I have a square prism. Why it is called a square prism? Because the top and bottom surface will have the same shape, whereas these end surfaces are connected with the rectangular faces. Okay, so this is a square prism. If I will cut this square prism, whatever shape I will get by cutting it, that is called as the development of solid. Okay, now I will cut this top edge also. Okay, suppose I cut this solid now. If I will open it and laid out it on a flat surface, okay, so this is called as the development of solid. Now, as it is a square prism, the development of square prism will consist of four equal rectangular faces, which represent the lateral faces of the prism, and two equal square at its end. One more square will come for the base of the prism. So this is called as the development of solid. Now we'll go to the technical definition. When the surface of solid are laid out on a plane, the figure obtained is called as development. Okay, so in the square prism we'll have the four rectangle and two equal squares will come at its ends as its development. Now let us understand. Each figure shows, if you see the shape of this figure, each rectangle will show the true size and shape of the corresponding surfaces of the prism. Okay, the development of solids thus represent the actual shape of all its surfaces when bent or folded at its edges would form a solid. So when you will open out, you will have the shape like this. So here I have already shown. So this is the development of the square prism. Four equal rectangle will come and two square shape will come at this A. Okay, so this is the development of square prism. Now, you will find the application of development of surface in many industries. Okay, the industries such as automobile, aircraft. In the automobile, the body part is the made with the development of surfaces where sheet metal work is used. Okay, also you will find the application of development in the area such as shipbuilding, packaging. Okay, the products which are manufactured from the sheet metal work. Also in the construction of boilers, hoppers, chimneys, furnace, or in all these applications, the development of surfaces, this knowledge is very essential. Okay, so according to the form of the sheet obtained by laying all the outer surfaces of the solid with suitable allowances this is known as a pattern. Basically, this particular method of the development of surface is very essential, and it is only used in the regular solid such as prism, pyramid, cone and the cylinder. If the shape of the solid is very complicated, if it consists of the plane surfaces along with the curved surfaces, then it is very difficult to develop the surfaces. So in this particular unit, we are going to focus on the method of the development and the development of lateral surfaces of the right solid. Okay, basically when you will go through the method of development, you will find that there are two method of development. One is known as a parallel line development and another is known as a radial line development. Parallel line development is basically used, it is employed in case of prism and cylinder, in which stretch out principle is used, whereas radial line development is used for the pyramids and the cone, in which the true length of the slant edge or the generator is used as a radius. We have seen the example of the square prism. Now we'll see the if it is a square pyramid. Suppose this is square pyramid. Okay, you already know the difference between the pyramid and the prism. Okay, now let us understand if we'll develop the square pyramid, how exactly its shape will come. So for that, what we'll do, we'll cut this square pyramid at its one edge. Okay, so I'm cutting this square pyramid and I will open this pyramid to get the exact shape how it will come. Okay, so now if I will open this square pyramid who will have the base of having the shape of the square. If I will open it, now you can see the square pyramid is consist of the four equal isosceles triangle. Okay, so the development of square pyramid will consist of the four equal isosceles triangle. To give better perspective of this development of the pyramid, I will show you on a dark background. So if I will open the pyramid, square pyramid, now you can see the development of square pyramid will consist of four isosceles triangle, four equal isosceles triangle. Okay. Now further we'll see how exactly the development of different solid will come, how exactly the shape will come. Okay. So we'll take one by one example now. In our syllabus, we have the development of lateral surfaces of the solid only. Okay, lateral surfaces only. We are going to develop only the vertical faces of this prism. We have already taken the example of the prism in which I have shown the top and bottom surfaces development also. Now, as we have the lateral surfaces development, so in the lateral surfaces development, we are going to eliminate the top and the base surface. Okay, so I have eliminated the top and the base surfaces. Now if we'll open this square prism again, who don't have the top and the bottom surfaces, now it will consist of, if I will eliminate the top and bottom surface, so now the development of lateral surfaces of the square prism will consist of now four rectangle, one two three four equal rectangle whose height will be equal to the height of your solid, and length, total length will be equal to the perimeter of the base. As it is a square prism, so the perimeter length will come equal to the four times of its one edge. Okay, so this is the development of the lateral surfaces of the square prism. Okay, now if it is a triangular prism means whose top and the bottom face will be triangle, these ends will be connected with the rectangular faces. Okay, so this is the triangular prism. Now if you will open the triangular prism, its development will consist of the three equal rectangle. Now see, its development will consist of the three equal rectangles. So this is the development of the triangle prism. Okay, if it is a pentagonal prism, then its development will consist of the five equal rectangle, one two three four five equal rectangle will come. If it is a hexagonal prism, in that case its development will be equal to the lateral development of that hexagonal prism will be equal to the six equal rectangles. Okay, and whose perimeter will become 6 into sides of this base edge, side of this base edge. So this is the developments of the prism. Development of lateral surface, as we have seen in the square pyramid. So the development of lateral surfaces of the square pyramid will consist of four equal isosceles triangle. In this also will eliminate the development of the base surface. Okay, if you will take the example of the triangular pyramid. Okay, if you'll take the example of the as the base having the shape of the triangle, and how you will identify this is pyramid, all these slant faces will meet at a point. This is known as the apex. If I will open this particular solid, this is a triangular pyramid. So if I will cut this and open, now let us see how which shape will come for this development. Now you can see if it is a triangular pyramid, then in that case, this development will consist of three equal isosceles triangle. Okay, if it is a pentagonal pyramid, then it will consist of five equal isosceles triangle. If it is a hexagonal pyramid, then in that case it will consist of the 6 equal isosceles triangle. I have shown in this figure also. Now you can see it. Okay, if it is a triangular, if it is a triangular pyramid, then its shape development will consist of 3 equal isosceles triangle. If it is a square pyramid, then its development will consist of 4 equal isosceles triangle. If it is a hexagonal pyramid, then it will consist of 1 2 3 4 5 and 6 isosceles triangle. Pentagonal pyramid, then in the pentagonal pyramid it will consist of 5 equal isosceles triangle. Hence we can say that the development of lateral surfaces of pyramid consists of number of equal isosceles triangle in contact. The base and the sides of each triangle are respectively equal to the edge of the base and the slant edge of the pyramid. This is known as a slant edge. So this slant edge uh, is known as a generator in case of pyramid. So this is the development of the pyramid. Now let us see how if we'll open the cylinder, how its development will come. So I have one cylinder. Okay, if I will cut this cylinder and open it, I will get one rectangle. So the development of lateral surface of cylinder is a rectangle having one side will be this side will be equal to the circumference of a cylinder. Okay, whereas this height, when I will open this cylinder, this height of the development will be equal to the height of the cylinder, will be equal to the height of the cylinder. Okay, so the development of cylinder, you got to know how the shape will come for the development of cylinder. Now let us understand how exactly the shape of cone will come if we'll open this cone. Okay, I have cone whose base will have the circular shape. So if you will open the cone, if you have the solid like cone, and if I'll open this, the development of cone will consist of a sector of a circle. Okay, in next videos we'll see how exactly to draw it. Now let us understand how the when we'll open the surfaces of the solid, how exactly the surface of those solid will come. So we can say that the development of curved surface of a cone is a sector of a circle. The radius of that sector will be equal to the generator. This is known as a generator. So when we'll open it, this particular radius will be equal to the generator, and this arc length will be depend upon the circumference of the base circle. Okay, there is procedure to calculate this particular included angle for the cone. We'll see it later on. Now I hope you got to know how exactly the shape will come when we'll open the solid. Okay,